So good afternoon, guys. You're once again welcome to our Sunday tonic, which happens to be our meeting point to discuss on the way forward on solar, precisely solar renewable energy. So we will be talking today basically on two things. We'll be talking about controller sizing, solar charge controller sizing, and cable sizing on solar projects. As you all know, the solar charge controller plays a very, very vital role in the solar inverter solar system because it actually helps in regulating how current gets current from the sun. It regulates the current from the sun that gets to our batteries and gets to our inverter, as the case may be. So it's actually a major component or a key component, because without a solar charge controller, we may be having issues with excess current going into our battery, which will obviously affect our battery lifespan. So that is why it's actually a very, very important component of the solar inverter system. I would like to share my screen from the previous class so that we can have a look at what we discussed last time. So that if we look at what we discussed last time, I think, okay, so can you all see my screen? Which of the screens are you seeing? Is it, which one are you seeing? Are you seeing
your folder, your entire folder?
The entire folder? Okay, sorry. Okay, so I'm coming. 1 minute. Okay, let me share it again.
Okay.
Okay. If you can see this, can you see what I'm sharing now?
Yes.
Okay.
Yes, we have seen it.
Okay, actually, what I want us to just have a quick recap from last week. If you look at last week, we simulated a particular load, which we all did some calculations and came up with certain things like inverter sizing. We came up with the size of inverter to be used. We all agree that we calculated and came up with a 1.5 kilowatt in 24 volts inverter system. We said, okay, if we are going to our daily energy required daily energy consumption is 7.56 kilowatt hour, and we went further to calculate the size of solar, and we got 1.6 solar sizing capacity. We got 1.6 kilowatts of solar to be able to deliver the required power. So now, what we'll be doing today now is we are going to continue from this particular load, which we have. I just want us to have it in mind that we talked of if we're going to use if we're going to use the lithium ion, we decided that you can get a 7.5 kilowatt lithium ion in the market directly, or if you're going to use battery, we came up with if you're going to use the lead acid battery, we said we will require up to 6 pieces of 12 volts 200 Ah batteries for it to support this load conveniently. So now I would want us to continue now. So now, if we say, okay, let me still share this screen. I think I stopped sharing that one. Let me share another screen so that we can work with it. Okay. Okay, are you seeing this screen now? It's actually an Excel sheet. Are you seeing it?
Yes, we are seeing it.
Okay, we said inverter.
Yes, we can see the Excel sheet.
Okay, we said it's a 1.5 kilowatt 24 volt system. We said assuming we are to use a lithium ion battery for this project, we said a lithium ion battery of 7.5 kilowatts at 24V. 24V. Hold on, please let me answer this call. Hello. So we now said if we're going by that previous load, we said a lithium ion of 7.5 kilowatt hour and 24 volts will serve. We went further to say our solar capacity is going to be 1.6 kilowatts or 1,600 kilowatts. So now what we are left with is cable type. We don't have it. Bam, 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 question mark. And controller type. We don't have it. So we're going to determine which type of those two things we're going to determine. So now let's start by looking at the cable sizing. Cable we're going to be using. If you look at it very well, you know, between the inverter and the battery, we need a cable to connect those two devices. We need a connecting cable. Between the battery and the inverter, we need a connecting cable. So now, inverter, battery, cable. Which type are we going to use? We said we already know that our load, maximum load from that particular maximum load was 725. Maximum load was 725 watts, right? So, and we say the operating voltage of the inverter is what? Is 24 volts.
Power off.
Is 24V. So now for us to determine the current that will be flowing through this cable, current that will be flowing will be simply 725 divided by 24, which gives us what? 725 divided by 24, which gives us 725 divided by 24, which gives us 30 amps. 30 amps. So now we know at maximum 30 amps maximum. That is when all the appliances come on board. That is when they're all powered. The maximum current that will flow between the inverter battery cable is 30 amps. Fine. So now we can simply go. I have a particular chart. It's very easy. You can easily get DC cable current carrying capacity chart online. They are very much available online. I have a particular one that I used to use. Let me still share it. Let me stop sharing this and share another screen so that we can see. Yeah. So I have, let me, bam, 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 bam. Okay. Share this particular screen. Okay. So I hope you can all see this screen.
Yes, we are seeing it.
Okay, so if you look at this screen, though this chart, this particular chart starts from 5 kVA. I wish I had the one that started from or from 25 mm. Sorry, let me use the word 25 mm. So I wish I had the one that was this is the chart I actually use alongside my guys. That is my team. We always use this chart. I have it on the WhatsApp platform we use. So if we're looking for cable sizing, we have a 5 kVA system. We actually go for 25 mm for battery to inverter connection. I think for the load we just calculated, the inverter is supposed to be around 2 kVA or thereabout, 2 kVA or 1.5 kVA. So, and the maximum current that will be flowing from the battery to the inverter and vice versa is 30 amps. So, I typically, in that case, a 16 mm cable can work. Unfortunately, it's not on this chart, you understand? Unfortunately, it's not on this chart, but a 15 mm should be able to, a 16 mm should be able to carry that amount of current conveniently. I don't know if you are with me. It should be able to carry it conveniently. So that is, this particular chart acts as a guide. Assuming now we have, we are using a 5 kVA inverter system. We know that the maximum current on peak load for a 5 kVA is 4,000 watts or 4 kilowatts, 4,000 watts. So the maximum power a 5 kVA can deliver is 4,000 watts. That is by multiplying by 0.8, which is the power factor, you understand, to get the real power. 5 kVA is apparent power, but 4 kVA is the real power. If you multiply it by 0.8, which is the power factor, you get 4,000. So at 4,000 watts, the maximum current is 80 amps. You understand? So, and this 80 amps, a 25 mm cable can conveniently accommodate it. The same thing applies if you look at the next one is, we're talking about a 7.5 kVA, which is 6,000 watts, and the maximum current is 120 amps. So a 25 mm should be able to accommodate that. And the same thing applies for various capacities. If you look at it, we have 5, 7.5, 10, 15, up to 50 kVA, and with their corresponding amount of current they can carry, they should deliver, then with a corresponding cable sizes you should use for such connections. So I don't know if this is very clear. That is for the battery cable sizing. Battery inverter connection. Battery inverter connection. Understand? Battery to inverter.
It's clear.
Okay, that's fine. So that is fine. So good. Then the next thing I would also like us to look at on this particular side of it is this one? Yes. So for this particular case, cable size should be a 16 mm size should be a 16 mm should be able to accommodate the 30 amps conveniently. So now that is for the battery. That is for the battery inverter connection, right? Inverter battery connection. Now, the next thing I would want us to look at is solar to charge controller connect, solar panels to charge controller. So solar to charge controller connection. So now our solar capacity we said is 1.6. Solar capacity is what? 1.6 6 or 1,600 watts. So now we want to determine which type of panels which type of cables we're going to connect between the solar panels to the charge controller. Fine. There are basically two types of solar charge controllers available in the market. We have the MPPT and we have the PWM. The MPPT is actually a better charge controller in the sense that it's much more efficient. It has the ability of converting more power from the solar panels to the if it has the capacity of converting more power or harnessing more power from the solar panel than the PWM. The MPPT charge controller, actually, it's the meaning of the MPPT is maximum power point tracking, solar charge controller. So actually, the way it works is the MPPT has the ability of converting all the excess voltages. If you look at our solar panels, let me break it down this way. If you look at your solar panels, you discover that your solar panels are not rated in 12 volts, but if you are looking for us, solar panels are meant to deliver power, that is to give out power. So you discover that the available solar panels in the market are actually higher in voltage compared to our conventional 12 volts, 24 volts, or 48 volts. So if you're talking of a 12 volt solar panel, if you go to the market, you look for it, a 12 volt solar panel will have a rating of 18 volts. Why is it so? It is meant to be higher than your battery voltage so that it will be the one to allow current to flow from itself. If it's at higher potential, it's just like if you want to pour water from one bucket to the other, you have to raise the bucket to turn water from that bucket to another that is on the ground. That is how it is. If you don't raise the bucket up, the water cannot pour to the second bucket or cannot be poured into the second bucket. So the same thing applies to these solar panels. The voltages are slightly higher than the conventional voltages we have in the market, like our 12 volts, 24 or whatever. If you're going for a 12 volts panel, you see it's rated at 18 volts because it is to actually deliver power from the solar panel to the battery. So if you're using a PWM, if you're using an MPPT charge controller, an MPPT charge controller has the ability, I just want to make it simplified, has the ability to convert all the excess voltages, if you have a 12 volts battery, you understand, and you have an 18 volts solar panel, 13 volts will just be sufficient to charge it, or 14 volts, which is just slightly above the battery voltage. So now what happens to the remaining excess voltage? It acts as waste, you understand? So, but the MPPT, if you're using a PWM, let me just make it very clear so that I can differentiate the two of them. The PWM will just convert, will have the ability of utilizing that immediate voltage that is above the battery to deliver power. So the remaining excess voltage are waste, you understand? That is why you find out that if you have an 18 volt system charging a battery to 13 volts, you find out that this battery, as it is on 12 volt, it will be trying to attain 13 volts, which is its maximum voltage, you understand? Once it reaches that maximum voltage of 13 volts, it stops charging. The PWM will only utilize that 13 volts produced from the solar panel to charge that battery. The remaining excess are waste. So you can see where the PWM becomes less efficient than the MPPT. The MPPT has the ability to combine to convert all the excess voltage from the 18 volts to all the excess voltage. It will convert it to current, because current is what is needed to charge the battery. It has the ability to convert all excess voltage on the solar panels to now use it as a current to charge the battery. So you can see where the MPPT becomes much more efficient, you understand? So, and another good characteristics of the MPPT charge controller is they usually come at higher voltage. You understand? If they come at higher voltages, it means you can combine a lot of panels, achieve a high voltage, because since it has the ability of converting, since it has the ability of converting since it has the ability of converting all this excess voltage, you don't have a problem of raising the voltage high. It can do the magic of converting all excess voltages to current, you understand? So, and you know, in power, once your voltage becomes higher, you understand, obviously current becomes smaller. So the MPPT controller has advantage over the PWM, you understand? Because by the time the voltage becomes higher, the current can be made smaller. And once the current is made to be smaller, you know, definitely a smaller diameter of cable can carry that small current and deliver that small current. So in an MPPT system, one of the advantages is you don't need a thick cable to deliver power from the solar panel to the, what do we call it? To the charge controller, if it's an MPPT system. So looking at this particular project that simulated project we're working on, we said the power is 1,600 watts from our previous calculation in the previous class. You discover that we have 1,600 watts of this of power. If we decide to go with a PWM 24 volt solar charge controller, let's say we are using a PWM controller that has 20 is a 24 volts, of course. You know, we want to determine the capacity. You understand? That is capacity. These solar controllers are rated on current in terms of current, whether it's PWM or MPPT, they are rated in amps. So if you decide to use a PWM controller that is 24 volts, and you know, since a PWM handles lower voltage, you see it, they will rate it. Let's take, for example, 50 volts, 50 volts max. So it means if we are going to use this particular solar charge controller, you understand, we're going to use this particular solar charge controller. It's a 24 volts MPPT controller that accepts PV voltage not higher than 50 volts. What it basically means is that if you're going to connect your solar panels to this particular guy, it means the voltage shouldn't exceed 50 volts, you understand? So it means the voltage shouldn't exceed what? 50 volts. So if we're looking at, okay, we want to deliver the maximum current, the maximum voltage is 50 volts, you understand? And we want to use it. Definitely, for us to determine the cable sizing, we have to go and say, okay, 1,600 divided by 50 volts, which is the maximum voltage, PV voltage, which is what? If we do that, we'll get, I think, 40, right? 40 amps, right? 1,600 divided by 50, 32 amps. I have 32 amps, you understand? 32 amps as the current that will be flowing from my solar panel to my charge controller. So now a 32 amps is what will be flowing. Obviously, from our previous discussion, we said a 16 cable sizing will definitely fall within the 16 mm cable, 16 mm diameter, right? 16 mm diameter is what will, if we're using a PWM. So now, what if we're using MPPT, an MPPT? So, and secondly, please, we have gotten cable sizing now. I will still come back to controller sizing on both on this, please. Still, controller size. Controller size. I will still come to controller size. I just want to do the difference first. So I also want us to understand the difference. If we're using an MPPT controller, right? MPPT controller that is rated 24 volts, you understand? MPPT controllers are rated higher, and it's, let's take for example 400 volts. You see it is rated higher, obviously, since it has the ability to convert all the excess voltage to current. It's rated 400 volts. Or let me not be too selfish. Let me say 300, or let me say 150 volts, please. Sorry, let me not go too high. Let's say 150 volts, right? So now, if we decide to go with this particular type of MPPT, you understand? Now, obviously, our power requirement still remains 1,600 watts. You understand? Then now, to determine the current, it's just 1,600 divided by what? Divide by 150. So, which is obviously 1,600 divided by 150. I have 10.6 amps, 10.6 amps. So this 10.6 amps, you know, obviously a cable of 10 mm, even 6 mm cable can serve. 6 mm cable can serve here. So I can use a 6 cable sizing will be 6 mm. You understand? What you see what it has saved us. So between your solar panel and your charge controller, if you're using an MPPT, because the voltage has gone up, the current has definitely what? Reduced. So we can use a 6 mm diameter cable for 6 mm cable diameter for our solar charge controller connection. So now controller sizing. Controller sizing. So you can see the major advantage the MPPT has. You understand? Aside the fact that it will convert all the excess voltage, it has the ability to reduce your solar cable sizing. Solar to a controller cable size is drastically what? Reduced in this case. Now, controller sizing. Controllers are rated in amps. Controllers are rated in what? In amps. We have various sizes of controllers in amps, you understand? They are rated in amps. We have 40, we have 20, 40 amps. So, but what will determine your controller size is overall load. You understand? Overall load that we got at 7.5. You remember we got our overall load as 7,000 overall load, which we got at 7,000. Sorry, peak load rather. Sorry, peak load. Peak load. Are you with me? Peak load, that is total energy consuming. That is the total power drawn from the battery. You understand? You need to be able to deliver enough power. You understand? Number one, please let me make some things clear. You know, your battery requires, what you're doing in a nutshell by installing solar panel is to ensure that you harness solar power from the sun to charge your battery. The battery will now be able to store your energy harnessed from the sun. If it stores it, later on, you now start pulling, as you use it, you keep pulling it what? Gradually, you understand? You start, what do I call it? You start pulling your load gradually as your stored energy in the battery. You need a charge controller that should be able to deliver your overload or your overall needed current into the battery. I don't know if it's clear. I'm just trying to get a better way of putting it. You understand? I'm trying to get a better way of putting it. I need a controller size that should be able to charge my battery. Okay, let me put it this way. The best way out is I need a controller that should be able to charge my battery within the shortest possible time. You know, the sun doesn't shine 24 hours. The sun shines within a specified period of time. You understand? The sun shines within a specified period of time. So we will need, as what do we call it? I will need a charge controller that should be able to charge this my battery within the time frame which the sun rises to when it sets. You understand? This charge controller should be able to charge my battery, or should be able to charge my battery conveniently within this time frame. You understand? Because you cannot use 24 hours to charge to calculate, to use it as a factor for charging your battery. You have to factor in when the sun comes in to play and rests, when it comes up and goes to rest. You understand? The time is almost up, so I don't know, maybe I will extend the meeting so that we will just round it up in the next 10 minutes or thereabout, please. You can rejoin with the link I will share shortly.